Alrighty, hi everyone. Hope you're all doing well today. Just some stuff to be aware of in general. You do have your next assignment due on Monday, so that's Tech Jobs MVC, I believe. There are 2 more assignments after that, and then we're done. Actually, the last day of class is 3 weeks from today, so we are getting very close to the end here. It's kind of amazing. Feels like we've been doing this for a little while. We have. We've been doing it since January. So, but the end is near. We can see the light at the end of the tunnel. So let's not slow down quite yet. We got 3 more assignments to get through. So we're gonna do everything we can to help you get those last few assignments wrapped up, and then we'll have a big party. I think that's it. Does anybody have any questions about end of class stuff or upcoming deadlines, due dates, things like that, before we talk about inheritance? So today's main topic was inheritance, and this is not the first time we've seen or used inheritance in this class. So the first thing that I wanted to do is kind of discuss, what inheritance looks like with Java versus inheritance in Python. Can somebody describe some of the differences between how the 2 languages treat this very important topic? How do I know I'm using inheritance in Python? What am I going to see? Anybody remember? Yeah, go ahead. Yeah, so I passed the name of the class I'm inheriting from. What's that called? We have a name for that. Class I'm inheriting from is called, I'm sorry? Parent class? Sure. Parent child, or might hear it called the, what? Superclass or the base class? Yeah, all 3 I would accept as proper ways of referring to that class. So we'll see that in parentheses in Python. What do I see in Java then? To indicate that we're using inheritance. Extends, yeah, we'll see that extends keyword when we're defining our class to indicate that we are inheriting from a different class. What else? Any other differences between the 2? The nice thing about these topics in general is that really they behave very much the same way, right? So inheritance in Python, has certain behaviors, has certain things about it that we can rely on, and those things are still true in Java. The syntax is a little bit different, but the general structure of inheritance and how it works is the same. So what am I inheriting? If I use extends to inherit from a base class, what am I inheriting? Data? Can we use, you're technically right, but can we use computer science terms to describe what we're, I'm sorry? Methods? Yep. What else? Except for constructors. We'll talk about constructors. What else? Methods. What else is in a class? We got methods and we got fields. That's it. That's what we're inheriting. We're inheriting all the methods and all the fields. Well, kind of, actually. So you can see I have a question down here. How do access modifiers affect this? So we've talked about access modifiers, right? Public and private. How does that affect inheritance? Yeah, so if I have something marked as private, whether it's a field or a method, I'm not going to get that from inheritance. That's going to be purely private to the base class. So the child class, the derived class, the subclass, whatever you want to call it, will not receive things marked private, which is a little inconvenient because, sometimes we would like things to be purely public. Sometimes we would like things to be able to be inherited, but not like extremely public, right? And sometimes we want things to be marked private. And so really, public and private aren't good enough anymore. And so we have a 3rd access modifier. What's that one? Protected. And so protected basically means that you can inherit this, but for all other intents and purposes, it's private, right? So it's a way of keeping access restricted, still keeping the variable, the field or the method relatively private, but still allowing it to participate in inheritance. What relationship do we use to describe inheritance? We talked about relationships between fields and classes and methods and classes. What do I use to describe inheritance? Yeah, that's what I'm looking for, right? So I think the example from the prep work used cats today. I can't remember. I think that they used cats, right? So tiger is a cat, right? A lion is a cat. A house cat is a cat, right? If we can say that out loud and it makes sense, then that means it's a good utilization of inheritance. All right, so we mentioned earlier that constructors were kind of left out of what gets inherited, but can I still access those constructors? See some people nodding their heads, yes. How? How do I access constructors if they're not directly passed along through inheritance? So if I'm using inheritance, right, but I want to call the constructor from my base class, what do I have to do? What's that look like? Yeah, go ahead. So we do have to use extend, that's how I do inheritance, but how do I actually call the constructor then? There's a particular word. Super, yeah, super. Referring to the superclass, right? The class that we are inheriting from, that will call the constructor from that base class. We don't have to do that. We are not obligated to call the constructor from the base class. In fact, if we don't do it, Java does it for us, right? It sets that up for us. But if we want to utilize an existing constructor from my base class, we can use the super keyword to access those constructors. So we still can use those constructors. In fact, super is useful for more than just constructors as well, right? We can also use it to access any methods from the superclass, from the base class. And I might show you some examples of that a little bit later on today. What does it mean to override a method? We've actually seen this before, right? Where have we seen overriding? I haven't actually explicitly pointed it out or, highlighted it that much, but we have seen it before. Where have we seen it before? ToString, yeah. What else? There's other ones. Equals and hash code, yeah. So what does that mean? What am I overriding in that case? Or what does it mean in general to override a method? We're redefining the behavior. So I got that method from my base class, right? But I don't quite like the way that the base class is using it or the superclass is using it, so I'm gonna redefine it in a way that I need to use it. So I'll override that method, basically saying the version that I inherited isn't quite good enough. I'm gonna override it and provide my own version for my subclass. So going back to toString and equals, they had override. What am I overriding? Where do those come from? If I'm overriding them, it implies that there was another implementation somewhere. Yeah. Every class, everything in Java is an object, right? I don't know how many times I've said that so far. It probably won't be the last time that I say it in this class. Everything is an object in Java. So toString and equals come from the object class. If I like the way that object implements those things, I'm free to use that, right? Most of the time, though, we don't. It's not useful to us the way that object implements toString and equals. So we go in, we override those methods, and we provide our own implementation that's more useful to us. We've seen several examples of that now. Did you have a question, or you good? Okay. All right. What is an abstract class? Yeah.
Class that's never going to be made into an object.
It's never made into an object. It's never, we have a word for that. Instantiated, yeah, instantiated. It's never, I can never make an instance of an abstract class, right? Why? That seems a little silly. Why? What's the big deal? What do we use it for then? If I'm never going to make an instance of it, then how does it help me? Yeah, go ahead.
We have, say, the animal was a human, so we don't have that. Implicitly, we have cat or lion, so there might be common features for all the animals. class, then instances are always going to be cat or dog.
Sure, yeah, so it lets me take some common behavior and put that in one place, my abstract class, and then I can still use inheritance on that abstract class, right? So I can still pass that behavior, those fields, those methods to other classes from the abstract class to the subclasses. But then, I never have a need typically then to create that abstract class myself. So you used animal as an example. Common one that you might see is a shape, right? I can make squares, I can make circles, but I can't make a shape, right? Like I'm not just gonna make a generic shape object. I'm gonna make something specific, like a triangle, circle, something like along those lines. But I can put, behaviors in that base class that allow me to utilize inheritance, even though I never intend to actually create an instance of that object. That should tell you, right, that inheritance is a very powerful, very useful tool. What's the main benefit then that we get from inheritance? How does that help us? How does that save us? We don't have to write the same code over and over, right? That's one of the biggest benefits of using inheritance is that code reuse. I don't have to write the same methods over and over. They can get passed along from one class to the other naturally. Good. Any questions? It's a tricky topic. We're diving deeper into it than we did, I think, when we were talking about it with Python. Does anybody have any questions about it? Let's talk about one other very important topic then. What is polymorphism? It's a very intimidating word, but an important concept to know. Go ahead, take a stab at it.
So I feel like it's kind of related to inheritance.
Mm-hmm. Mm-hmm.
But this idea of, okay, let's just use animals for example, as the superclass, and then below that is about all these different subclasses like purple and lion and whatever. But I feel like they all come from the same superclass, but you can use them in a collection together. Could build a collection of three that has the same.
Yeah, there you go. So you kind of hit that last part there, especially as a common way that we use polymorphism, right? If I have inheritance, if I'm using inheritance, I've got a whole bunch of different subclasses that all inherit from the same superclass. Polymorphism allows me to treat those objects as the type of the superclass if I want to. So if I have a cat class and then a whole bunch of different cats, right? I have a tiger, I have a lion, I have a leopard. I can actually treat a tiger as just a generic cat if I want to, which allows me to collect tigers and leopards and lions all together as one pool of cat objects instead of having a separate pool for tigers, a separate pool for lions, et cetera, et cetera, et cetera. So if we can boil it down, the essence of polymorphism, right? The essence of polymorphism says that I can treat an object either as its exact class or any of the classes that it inherits from, which means that I can change the type of that object to any of the classes that it inherits from, if it suits me, if it's useful for me to do so. We see that often with collections. We'll see an example today of polymorphism using a collection as well in our coding example today. It's a very, very powerful tool, very powerful tool. And we'll talk about it more, I think, when we get to code, because it's a little easier to see it in action than to talk about it in abstract terms. Are there any questions about it right now, though, that I can answer? It's a tricky concept. I promise you we'll see an example later, and this is going to help us transition then into our coding exercise. We talked about class diagrams before, right? So there's three main things that I'm currently interested in representing on a class diagram, right? Which are fields, methods, and inheritance. Those are the three big things that we've talked about in terms of object-oriented programming in the last three classes, including today, fields, methods, and inheritance. And so what I want to do, earlier I distributed a class on Slack. So maybe you saw it. If you want to code along with me today, you can grab that class and load it in IntelliJ, or you don't have to if you just want to sit back and and relax and enjoy the show for today, that's fine with me as well. It's a bank account, right? It's a class that represents a bank account. So you can see that my bank account has an ID number, it has a balance, how much money is in the account. I've got two constructors here. I've got a couple constructors, and then I've got a couple methods. I can withdraw money from my bank account, or I can put money into my bank account. I can make a deposit, right? It's not meant to be terribly complicated. I did stick a two-string method down here as well. We talked about that last time in class. It's not a particularly complicated class, or at least it's not intended to be a particularly complicated class. And so what I want to do first is create a class diagram for this, which is kind of the opposite order. Normally I would start with the class diagram and then turn it into code, but we'll do a little bit of that later. So I wanted to kind of start going the opposite direction today. I've got some code here. I want to turn it into a class diagram. So I've got a website pulled up. It's called Drawio. It's a free website that allows you to make diagrams. It's not the only one. There are lots and lots of other diagram drawing tools available online. This is just one that I happen to know and happen to use a fair amount. And it provides a whole lot of stuff for UML, which is exactly what we're talking about. And so I can drop a class diagram out here. Here we go. And you can see that it's kind of helping me out already by labeling the different sections that I've got. So I can come up here and replace this with the name of the class, which is a bank account. So what is it actually telling me here? This plus means what? Public field, which is like a huge no-no, right? So that's definitely not true. And then this is the name of the field, right? So if I refer back to my bank account class, I've got two fields. I've got one called account ID, another one called balance, all right? So account ID, I think that was capitalized. And then the type of this was, I think, just an int. And then I'll put another one, minus balance. The type of this was, I believe, a double. So in the top box, I've got the name of the class. In the next box, I've got the fields, including the types. And then in this box, you can see I've got the methods. So I had two methods, I believe. I had withdraw, oops. And I should also include, right, the types of the parameters. And then what's this type referring to? I'm sorry? It's the return type, yes. So if I look at the withdraw method here, I can see that I have a parameter, a double, and then the return type is also a double. So I can indicate that on my diagram, right? Notice that I'm not putting the names of the parameters in here. It's not considered relevant for the design, right? Because names can be whatever you need them to be. We're just interested in defining how I interact with the class and the methods. What do I need to feed in, and what am I going to get back out, right? That's what I'm interested in defining here. And so then, whoops, I guess I need to stretch this box down a little. What? You're not going to do that for me? Okay, fine. What are you doing? Being a little difficult? Well, maybe if I type something? No, okay, great. This is fine. Deposit. I'll fix it in a second, maybe, if I know how. Oh, cool. There we go. That did it. I got it. Okay, and so here is then a class diagram for my bank account class, right? It captures all of the important pieces of the class. Now you'll notice I actually left something off. What about toString? Should I throw that in there? Sure, why not? I mean, so this is where some people, you know, I think there's a little bit of flexibility here. Some people would say toString is such a common method that I don't need it cluttering up every single class on my diagram, whereas other people are like, no, I want to document every single little last detail of the class, right? So this is an area where I've seen some wiggle room, one way or the other. We can put it in. It's not that difficult, right, to throw it in there. Some people might consider it to be a little unnecessary, but for the sake of completeness, we can put it on there. And so we now have a complete diagram showing our bank account. What about constructors? They're not on here either, right? Do I need those on here? What do we think?
Well, no, because those aren't inherited.
They're not inherited. Well, I haven't actually even gotten to inheritance yet, but I'm going to in just a second. That is a good point. I mean, is that a reason to keep something off of, because private values aren't inherited either, right? And yet I still included those, right? Should I include my constructors here? Do you remember from the prep work? Anybody? You don't recall including the constructors, but you also don't recall why they didn't include the constructors. That's a good point. So I think I agree. My memory is a little fuzzy, but I think I agree with you that the prep work did not include the constructors for the objects. As to why, I think that's probably another area where you could maybe argue both sides of that coin, right? If you are doing, if you have a lot of constructors, it might be worthwhile to see the various ways you construct that object, but constructors are also typically not going to be, the most interesting piece of your classes. They're also a piece that's required in every single design, so you can make the argument that, they're just going to clutter up my design because I'm just going to be having them all over the place. Design is inherently going to be subjective, so there's going to be some areas where some people may do things a certain way and you might not agree with that, and you might want to do it a different way. That's just part of the design process. I'm going to leave them off to match what the prep work does, or what I think the prep work does. And then what I want to do with you next is think about how we can use inheritance to, make some additional objects that rely on this bank account. In fact, if you go to the bank, you don't just say, hey, I want to open a bank account. You have to be a little bit more specific than that, right? You have to say, I want to open a checking account, or I want to open a savings account, right? So those are both bank accounts. In fact, if we use our relationship, right? Checking account is a bank account. Savings account is a bank account, right? So that's, I think, a good example of how we could use inheritance to make the bank account class a little bit more useful. So let's do that. How do I represent inheritance on a class diagram like this? What am I going to see? I'm sorry? You said,
You were saying lines, and I was saying lines, kind of like a pyramid, almost like.
Like a pyramid?
Class or something,
Yeah, it'll be an arrow, right? Pointing from the subclass to the superclass. Yeah, so I need to make my subclasses first. We need to decide what the design of those subclasses is going to be first. I'm going to keep it pretty simple, but here, I'll drag another box out here. We'll make this one a checking account. And, if there are any bankers out there, I'm going to greatly simplify this, but I'm trying to, think of ways that checking accounts and savings accounts are different. And one way that I can think of is that usually, not always, but sometimes you get charged a fee to have a checking account open, right? So at our bank, we're going to say that, this checking account has a fee associated with it that you have to pay to keep the account open. And so down here in the fields, I'm going to mark it private, of course. I'll have a fee, which is probably going to be a double. And then in terms of my methods, I guess I could have left it public. I'll have another method here called, deduct fee or whatever, that's going to, the bank's going to take their money, right? The fee that they charge to keep the account open. What should the return type for this be? I don't know. We could have it be a double, like the other methods that we see up here. All right, and then I'm going to make another class called a savings account. And again, this is a great simplification of what a savings account is, but savings accounts can earn interest. I know the interest rate is like nothing anymore compared to what it used to be, but they still technically do give you some interest for keeping money in a savings account. And so we'll add the abilities then to compute that interest and give interest to whoever owns this account. So we need, for fields, what field are we going to need? The rate, yeah, or interest rate. Oh, I shouldn't have capitalized it, sorry. And that'll be marked private. And that'll probably be, what, a double? And then for a method, we'll do compound interest. And we can return a double here too. Okay? Well, so it's already a field, so I should be able to just access the field directly instead of passing it into the method, yeah. This kind of assumes that the interest rate is not going to change very much, which is kind of true, but not 100% entirely true. The interest rate does change over time on a savings account, but for the purposes of this example, we're just going to say that whatever interest rate you get on the account is what it's going to stay at. Okay, and so the last thing that we need to do is represent that there is an inheritance relationship between my two checking account, savings account, and the bank account. So I need to find an arrow over here. I think there's one that even says, yeah, there's one that even says extends. That's fancy. And I can hook them up. I need another one for the other class. You can't really see the arrows very well because they're so short. But they are there. There we go. And here we are, a very simple class diagram that now utilizes some inheritance to make some, more specific kinds of bank accounts than what was previously available to us. Our next step is going to be to actually implement these things then, right? And take a look at how we can use inheritance in our code to implement this design. So we're going to kind of go in the opposite direction now. We're going to use our class diagram to help us implement the classes. And we may find that we've got to tweak some things along the way to make it work. That's not unusual. Designs are not always set in stone. They can be flexible. But does anybody have any questions before we start actually coding up these things? So I already have a bank account class. I gave you that bank account class on Slack. So what I'm going to do is I'm going to make two more classes, one for the checking account and one for the savings account. So I'll create a new class called checking account. Right? How do I tell it that I'm using inheritance? Again? Extends bank account. And it's mad at me already. There is no default constructor available in bank account. Does anybody know what that's talking about? Yeah.
Well, so I'm assuming the class with a structure that taken from this, and I feel like when you are here to class that has that
Yeah, so you're on the right track, actually. We're getting kind of deep into how inheritance works here, but this is a good thing, right? First of all, let's just take a step back for a second. What is a default constructor? Can we start with that? Does anybody know what a default constructor is? I'm sorry? Doesn't have any arguments, no parameters, right? Default constructor is name of the class, parentheses, done, right? And it's saying that I don't have one, which is true. If I go back to my bank account class, I do not have a default constructor. I've got two constructors, but they both have parameters, so none of these qualify as a default constructor. So that's what a default constructor is. But then the second question is, well, why is it mad? Like, why is it angry that I don't have one? That's sort of the other, maybe the more confusing bit to understand. So if I create a checking account object, then one of the things that it needs to do is call the constructor for the bank account class, because that's what it inherits from, right? There's two ways that this can happen. Either I can tell it exactly which constructor from the superclass I want to use, so I can say, use this very constructor. Or if I don't tell it which one I want to use, it's gonna use the default one. But we don't have a default one, so it's unhappy that that is in fact the case. So there's two ways we can fix this. I can create a default constructor, or when I create my constructors for my checking account class, I just have to make sure to tell it exactly which constructor from the bank account class I intend to use. Those are the two possible solutions to this problem. That is, I know, a very a kind of complex thing to wrap your brains around, but it's still something that I struggle with, actually. But let's go ahead and start writing some code and see if we can solve this problem. So when I create a checking account, what information am I expecting to pass in to make this checking account? Or actually, I skipped a step, right? I made this whole design to follow, and then I skipped a step. I need my field. I need this fee. My fault. All right, so if I'm creating a checking account, right? If I want to call the constructor, what parameters do I think that I need here in order to successfully do this? What's the constructor's job again? The constructor's job is to do what? I'm sorry? To assign all the fields, make sure all the fields have a value. So how many fields do I have here to worry about? 3. I have the fee that I just put in there, plus the 2 from the base class, right? So I have to decide where those 3 values are coming from. And so one way to do this is to just say, all right, they all got to be passed in as parameters. And I'm fine with that. I don't have a problem with that. ID double balance double fee. Okay? So that's fine with me. We can just accept them all. And then it's my job now to make sure, right, that all of the fields get set. So how do I access the ones from the base class? What do I do? If I want to get to the account ID field, how do I do that? Ah, there we go. Super. So I can actually tell it to call the constructor from the bank account class of my choice. Remember, I have 2 of them here, right? And the one that probably makes the most sense, I think, is, oh, actually, this constructor is incomplete. I missed that before class, sorry. The one that makes the most sense to me is probably this one, based on what we've discussed so far, because I can pass the ID and the balance in, and it will take care of that. And notice too that it's now not mad at me about the default constructor anymore, because I've told it exactly which constructor I want to use. It's no longer worried about having to call the default constructor. Also, by doing this, this takes care of 2 of the 3 fields that this constructor is responsible for setting, right? Because I'm just leaning on the existing constructor that's taking care of those 2 fields from the superclass. So I just have 1 field remaining, which is this guy, to worry about, and we can set that the way that we normally would. So this looks different from most of the constructors that we've written so far, but my claim is that it still does what a constructor is supposed to do. It still makes sure that all 3 values are set, all 3 fields from this class are set, the 2 from the base class as well as the 3rd that's in the subclass. Are there any questions about this? Yeah.
So in the superclass, we have 2 fields.
Yes.
Private.
Yes.
So then the checking account class inherits from the bank account class. It still, and we create an instance of the checking account. It still has those 2 fields plus the extra 1. And where the access modifier comes into play is when you're inside the checking account class, you can't explicitly just change the 2 variables.
Right. Right. In fact, we're going to see how the access modifiers are going to affect us in just a moment here, right? If I want to complete my design, the last thing that I have to do for my checking account is write this deduct fee method, which is, probably as simple as you would expect. I'm just going to subtract the fee from the account balance, right? So it shouldn't be terribly complicated. We can follow the design set out. Oh, wait, there was no parameter, was there? No, there's no parameter because I already have the fee. It's a field, right? All right. So I want to say this dot balance, oops, minus this dot fee. And you can see that it's upset with me because if I look at what it says here, it says balance has private access in the bank account class, meaning I'm not allowed to touch it here. I'm not allowed to do that. There's two ways actually I can think of that we can get around this problem. Does anybody know one of the two? I could change it to protected, so that's one solution. I can go here. I can say protected. And now, I believe it should be, oh, I need to return something, probably the balance, the updated balance. And I also, this statement is just wrong. What's wrong with me today? Sorry. It's been a long day. There we go, that's a little bit better. But still, we had to change that protected. That's one way we could have solved this problem. Can anybody think of another way we could have solved this problem? Yeah. Create a getter? Yeah, actually I agree with that. That wasn't the way I was thinking of, but we could have created a getter or a setter. Actually, we would have needed in bank account, but we actually kind of have one. Yeah. You can. Well, no, I don't think that would work. It would still be private, so it would still be upset about that. Yeah. But I do have access, remember, to all of the methods that are available to me. And what is a fee but, taking money out, right, of an account, which is a withdrawal. I could have called the withdrawal method because I have access to this method because I inherit everything from the bank account class, including the method. So, I could have rewritten this as actually a one-liner, right? Return, withdraw, this dot fee. That does the same thing as the code that I had up there 2 seconds ago. It's a little bit shorter. It's a little bit misleading because I don't know if a fee and a withdrawal, they're not exactly the same things, right? Like bankers, if there are any bankers in the room, they're probably like pulling their hair out like, it's not the same thing. But for all intents and purposes, it gets us at the same place. We took money out of the account, right? And I mean, the one advantage of doing this is that it does then, we don't have to change that access type to protected, right? We don't have to do that. I can leave it as private. And from a security perspective, we always want to restrict things as much as we possibly can. So I don't want to switch things to protected unless I absolutely have to. That being said, if you did it this way, I'm not going to be unhappy about that. I think this is perfectly fine. I think this is okay. Here's another little question for you though, right? In order to implement it this way, I had to change this to this value to protected, and now my design is no longer accurate, right? Because here, balance is still marked as private. How do I update this to reflect that it's no longer private and that's now protected? Does anybody know? Well, let's ask Google. UML protected. Here we go. What does the, I think it's called hashtag these days, but it used to be called pound. That's what we use to indicate a protected value. So I can switch this to pound to now accurately reflect that we had to update our design a little bit to make the inheritance work the way that we wanted it to. Okay? Yeah, what's up? So it's not just a security perspective. So the question was, if we're the only ones who can access the code, why is private better than protected? It's not necessarily to protect yourselves from outside people, although oftentimes that is what it's for, is to protect other people from accessing things improperly. But it's also to protect yourself from accessing things improperly, right? If I mark something as private, then that really truly means that nobody, even me, should not be accessing that value directly. And so protected is kind of the same idea. You know, I can mark things as protected if it's useful for my design to do so. But the first rule of security, actually I'm not a security expert, so I shouldn't say stuff like the first rule of security, but one of the main tenets of security is keep things as locked down as possible. Always, always, always. If you want to loosen the restrictions on something, then you have to have a reason to do so. And you know, I agree with that from the perspective of our access modifiers as well. Any other questions before we do the savings account? Yeah, what's up? Yeah, of course. Oh wait, that's the, were you looking for the checking account?
Yes. So, in the left view method, like the all purpose called draw method.
Yes.
But I didn't see you call it on.
That's correct. So I didn't. I just called withdraw. Actually, so if I type withdraw here, $100, right? Whatever. Oh, that's whatever. This works. It's equivalent to, and I usually try to type it like this. It's equivalent to this dot withdraw. Yeah, those two lines are the same. It does look even more out of place here though, because we have to remember that, oh yeah, we're using inheritance, which means that withdraw is not in this class. I'm calling it on, you know, I'm calling the implementation for my base class. All right, let's do the savings account, and then we'll do a little bit of polymorphism after that. So I'm going to make another class called savings account. And, you know, we have sort of a similar process here. This might go a little bit quicker since it's kind of the same idea as our checking account class. I need to make my interest rate field here. Private. Oh, wait, I need to do my inheritance. I almost forgot. Private double interest rate. I need to make a constructor. And, you know, we want to keep things simple. I could just take in all three values like I did for my checking account. So I would need an ID. I would need balance. Oh, it's an int. And, oh gosh, too many commas. And interest rate. And like before, I can call the constructor from my base class and pass those values. And now I'm just on the hook for the remaining one, right? This is all kind of a rehash, a little bit of what we did with the checking account class. And then the last thing for me to do then is to write the method that's included here, compound interest. It's another fairly simple method. I'm going to take the balance, I'm going to multiply it by the interest rate, and then I'm going to add that value back to my balance. I'm just going to keep it simple and straightforward. So, interest equals this dot balance times this dot interest rate, and that's probably going to be a double. And then this dot balance plus equals interest. Return this dot balance. There we go. Very simple interest computation. Notice that if we hadn't already turned balance into a protected variable, we would have had to do so here as well, because I'm accessing the balance here. Notice that account ID is not been accessed anywhere, so I have no reason to mark that as protected. I should leave that marked as private, right? No reason for me not to do that. Are there any questions? Any questions? All right, last thing I want to do is a little bit of polymorphism, right? So what I'm going to do next is create one more class, really just to, I'll call it bank. And in this class, what I want to do is create some accounts. I can create a checking account, I can create a savings account. I can also create a generic bank account, right? Which, whether I should be able to do that or not is an interesting conversation. Should I just be able to create a generic bank account? Can I go to the bank and say, give me a bank account? No, they're going to say, give me, you want a checking account, you want a savings account, you want a money market account, you want whatever. So that's an argument for then doing what? Yeah. Making bank account an abstract class. Yeah, that's an argument for making bank account an abstract class. Absolutely. Whether you want to do that or not, I'll leave that up to you. I'm going to leave it as is for now, but I think there is a strong case for marking this as abstract that we just talked about. But I want to do a little bit of polymorphism to wrap up today. So I'm going to make a main method. And I'm going to create a checking account and a savings account, right? So checking account, C equals new checking account, and I have to provide it with an ID number and a balance. We'll start with $100 and a fee, which is like $5. Okay? And I'll make a savings account. S. Oops. And we'll give this an ID number of 10, and we'll start it with $500, and the interest rate will be like, the actual interest rate today is like this. Well, yeah, for all intents and purposes. Okay, so I now have two accounts, right? And I can call any of the methods from the base class or the derived classes on the respective accounts. So, if I want to deposit to either one, I can do that, right? If I want to withdraw from either one, I can do that. If I want to compound interest, I can only do that on the savings account because checking accounts don't have interest rates associated with them, right? So we've used inheritance to help us keep the similar behavior in one place in our superclass and the different behaviors in separate places in the checking account and the savings account. But what I can do, if I'm a bank, right, which I'm not, but if I was, I want to have all of my accounts in one place, and I want to have a way of going through and checking all of my bank accounts. And so how we would do that in code is probably to maybe create an array list and put all of my accounts on there. But to do that, remember that for an array list, I have to specify the type of the things that are in there. So can I just say, checking account here? I mean, I can. There's nothing wrong with this statement, but then I cannot put savings accounts in that list. I'm not allowed to do that. And the opposite's also true. If I list the type of this array list as a savings account, I cannot put checking accounts into that list. But there is a type that I can put here that would allow me to do both. Bank account. If I use the superclass, the base class, whatever you want to call it, right? I can now put checking accounts in this list. I can also put savings accounts in this list because I can treat an object as its superclass if it's in my interest to do so. This allows me to create a collection that has all of the accounts in one place. And so I should be able to say accounts.add C, accounts.add X. And now I've got a list that I only have 2 accounts here, but I can create as many checkings and savings accounts as I want and add them to this list. That's okay. It's totally fine. Question?
So in that array, your third field, we'll call it, is different. One is a deduction amount. So, but it goes into the array list in the same spot?
Yeah, so the point that was brought up is that the third value here is different. They mean different things for each one, right? One is a fee and one is an interest rate. But I can stick them all in the same collection. The answer is yeah, absolutely. But here, let's talk about the implications of doing that, right? If I pull something out of this list, what can I do with it? Can I compound interest on that thing?
You need a way of knowing what you get.
I need to know what it is, right? If I want to do something that's specific to one of the types of accounts, like compounding interest or computing the fee, I need to know that it definitely is one of those things. And I can't. There's no way for me to know that. All I know is that it is a bank account. So I can use anything that is in the bank account class. Like if I wanted to give every single account, $500 because I'm feeling very generous today, right? I could go through every account in the list and deposit $500 into every single account because I know they're bank accounts, and I can deposit things into bank accounts, right? That all works just fine. In fact, we can write that loop. Let's do that real quick. For, I 0, I less than accounts. Oh, I accidentally a thing here. Size, I plus plus, right? I can say bank accounts B equals accounts.get I. So get me the next value from the list, and then I can say B.deposit. In fact, IntelliJ knows this, right? It sees the variables, it also sees the methods. Notice that it computes interest and deduct fees, not on this list because I don't know if it's a checkings account or a savings account. I know that it could be one of those things. In fact, in this case, I know that it is one of those 2 things, but I don't know which one it is. And I don't really have a good way of finding out, right? So I can say, deposit $500. I can even print it out. Because I have a toString method in my bank account class, right? I can print it out, but I cannot use the specific stuff. So I can run this and we can see that in fact, it's not going to do what I want it to do that well though. Whoops, yeah, I ran the menu. I didn't mean for it to do that. I ran the wrong thing. Let's try again. There we go. ID 1, balance 600, ID 10, balance 1,000. So I can see that $500 did indeed get added to the starting balances of each of those accounts, right? It worked. But notice it did not print out the interest rate or the fee because it doesn't necessarily know what to do with those things. And so then I can do withdrawals, yeah. Anything that's in the bank account class I can do here because I know those are bank accounts. This is polymorphism in action, right? I know that these are checkings or savings accounts, but I'm treating them as the superclass. I'm treating them as bank accounts because I want to put them all in one place. But the downside of that, or it's not necessarily a downside, it's just something you need to be aware of, is that if I need to do things like compute interest, I can't do that here. One thing that you might consider trying is, casting, right? We've talked about how to convert something from one type to another type. I can try to cast something to a different type, which might look like something like this. Checking account in parentheses, B, right? Oh, I guess I need to make a different name here. I'm running out of good names. C account. I don't know. And you'll notice that Java's not unhappy about this. And in fact, it'll probably work maybe once for the first item on the list, but it's not going to work for this one. When it gets to the next one on the list, it's going to say, oh, that's not a checking account. You're trying to turn this into a checking account, but I have no idea. This isn't a checking account. I have no idea what you want me to do. And the whole thing's going to crash at that point in time. So this is not a safe thing to do. And so your question might be, well, then what if I want to access all the checking accounts? What if I want to access all the savings accounts? What's the solution to that? Anybody know? Don't overthink it. Yeah, make a separate list. Make a list for your checking accounts, make a list for your savings accounts. That's exactly right. The general rule of thumb that you should consider if you're using inheritance, right? If you get to a point and you're like, well, I don't know what the exact type of this value is. I need it to be this thing, or I really want it to be this thing, or I want to check and see if it is this type, but I don't have enough information. I can't determine that myself. That means that your design is off. That's a very classic indication that, well, you probably designed something off. If you find yourself trying to cast like this line of code here, that's an indication that, well, actually, your design's off. Maybe you need a separate container for things of that type, if that's something that matters to you, right? A separate collection for things of that type. When you're using inheritance, while you certainly can cast things, typically that casting is one directional. I can take a checking account and cast it to a bank account. In fact, that's kind of what I'm doing here. It's not a cast, but as soon as I add them to that list, I'm now treating them as bank accounts instead of checking or savings accounts. So going in that direction is usually fine. I can take an object and treat it as its base class. That's not a complicated thing to do. That's pretty simple. It's pretty straightforward. But the opposite is not, it's kind of frowned upon to try and do that. I don't want to take something that is a bank account and try to turn it into a checking account. And if I'm trying to do that, that's an indication that, well, I should have made a collection for checking accounts somewhere earlier in my code, if that's something that I really wanted to try to do. These are all things that are going to take practice. I'm saying this to you now with the full expectation that you will someday try to cast something inappropriately and then see firsthand why it doesn't work too well. Happens to me all the time. It's a common programming trap to fall into. There are many Stack Overflow posts written about that exact thing that you can go read up on if you want more information about it. So polymorphism, while extremely useful, you do have to think about how to use it properly to achieve your goal. Yes. Does anybody have any questions? That's all I had for you. I'll post this code on Slack at some point today, but does anybody have any questions before we break up? Yeah, what's up?
Would there be any downside from inheriting from, say, like a subclass of thing? So, like, I noticed for your checking account, could you just, like, for example, from savings account, because that's inheriting from bank account?
I could inherit from savings account. Yes, that is possible. So inheritance can go multiple layers deep. We call that a hierarchy. That is entirely possible. And if you think about it, we're using it all the time already because everything is inheriting from object. And now I'm adding another layer on top of that, right? So I can do multiple hierarchies. However, it does need to make sense. So the example that you just said to me is, couldn't I have just had checking account inherit from savings account? And the answer is yes. Technically, I can do that. I can write the code and the code will work. But the thing to think about is, does that logically make sense? If I say that relationship out loud, checking account is a savings account. Does that make sense? I don't really think so. I don't think that statement makes sense, which to me indicates that it's a poor design choice, even though Java is not going to stop me from doing it if that's something that I want to write. And that's the tricky part about design, right? Java is not going to correct your design. Java doesn't care. As long as you write correct Java code, your computer's going to run it. It doesn't know if your design's good or bad or somewhere in between. It has no idea. That's something that humans care about and argue about and get in fights about, right? The computer can't weigh in on that decision, although it can give you some clues, like when using polymorphism, that your design is perhaps not as good as you thought it was. Great question. Any other questions before we break up? Yeah, what's up?
So, if you guys want to see iterating
Mm-hmm.
we wanted to do something to all the everything that's in the list. Then we wanted to do an additional thing to checking. Could we do with that condition that you have to cast the element inside of the list of checking account? Could that as a condition, additional, say, we'd have to turn true if we do it, false if not, and end up with the way.
Yeah, so technically the answer to your question is, is there a way to do casting where we can like check to see if it is this thing? And technically the answer is yes, the constructs for that do exist, but just because something does exist doesn't mean that it's a good idea to use it. So I am intentionally not going to tell you how to do that, although I expect that you will probably stumble upon it at some point. Whether I tell you about it or not, there are things that Java can do in that regard. But that, again, is an indication to me that it's a poor design, right? If you find yourself doing that particular thing, it's a sign to me that it's a poor design, and you should maybe back up a little bit and think about doing it properly, because even if you get it to work in that particular situation, it's going to have a ripple effect and screw other things up down the line. Yeah.
So wouldn't you, in that case, want to add like an extra field in the design of, like C being a checking account, S being a savings account, and that way you can say it's that.
You could add a field to the bank account class, right? But that becomes a little bit problematic, because then what if I decide to have a different type of an account? Now that field is no longer valid anymore, right? Possibly, I think asking an object, the general point that I'm trying to make here, and maybe I'm not doing a good job of arguing why it is the case, but asking an object what it is generally considered a bad idea. If you do not know what an object is, then you made a wrong turn, right? You need to back up a step. So in this case, a bank would have a list of checking accounts, and a list of savings accounts, and a list of all accounts, right? And it doesn't actually cause much extra work for me to create those additional lists either. It causes very little effort to split it up into those categories. Very, very little effort. Any other questions? Fantastic questions, by the way. Keep them coming if you got more. Love talking about this kind of stuff. You're really digging out the corners of my knowledge on some of these topics. It's a lot of fun for me. So thank you for that. I'll go ahead and get out of your way and let you work on today's studio and or the assignment that is due on Monday if you need to. And we will regroup at 8 o'clock like we always do to have a chat about the studio. Thanks, everybody.